Yes, ladies and gentlemen, welcome to the calculus jungle. Our topic today is going to be titled Tricky U Substitution. Now, before we dive right into the tricky problems, I want to review two problems first. The first one will be an indefinite integral, and the second a definite integral. So recall that an indefinite integral is an integral without bounds. So let's go ahead and attack our first problem here. Let's integrate cosine cubed of x times sine x dx. Alright, so do we need U substitution, or can we integrate this on our own? Well, we cannot split. We need to get that through our head. I can only split if I'm adding or subtracting, and I'm clearly multiplying these two trig functions together. So I can't just integrate cosine cubed and sine x. Second of all, if I know who to take the derivative of to get this as my answer, then I don't need U sub either. But in this case, I have no idea who to take the derivative of to get that. Perhaps you do. So I'm going to go ahead and use U substitution. Now, if you're not sure which one to pick, sine or cosine, clearly you could try one, and if it didn't work, try the other. But I'm going to rewrite this one more step, and I'm going to say this is the quantity of cosine of x cubed times sine of x dx. And we used a little hint in class. We said probably start by picking whatever's in parentheses or under a radical. So I'm going to pick cosine x as my u and see if that works. So just off to the side, if u equals cos x, remember derive both sides. Du equals negative sine x dx. My goal is to solve for dx, so I'm going to say that's du over negative sine of x equals dx. Alright, now recall it's called U substitution. I picked my u, now I need to substitute something. Since I solved this equation for dx, I'm putting it in place of this dx in my original problem. So again, I'm going to rewrite this as the quantity, and instead of putting cosine in there, I called that my u cubed sine of x, and in place of my dx, I'm writing du over negative sine of x. Alright, so my goal is to have one integral in terms of one variable. And we notice this will work out very nicely because this sine x on top will cancel with this sine x on the bottom. I just got to watch that negative there, so I'm going to pull that out front. And I'm really just integrating u cubed du. And that's a pretty straightforward integral. It's just like x cubed. So I'm going to get u to the fourth over 4. Make sure I leave that negative out front, of course, in plus c. And technically that is my final answer. I'm done there. Now at this point I just want to make sure I can match my answer to the multiple choice answers, and if I don't see anything in terms of a u, that's simply because they plugged whatever I called u back in. So if I scroll back and kind of look, I believe we said u is cos x. So I'm just going to replace my u with cos x. So if I don't see this choice here, I'm going to go ahead and rewrite it as negative cos x to the fourth over 4 plus c. Now again, perhaps I won't see that answer, so I just want to make a note that that's equivalent to, I can put this 4 back right here on my cosine, so I'm going to say that's negative cosine fourth x over 4 plus c. And there you have it, hopefully a nice easy review of an indefinite integral with u sub. So let's go ahead and try a definite integral now. Alright, so we've got the integral from 1 to 5 of x over the square root of 2x squared minus 1. So hopefully you've identified your u as 2x squared minus 1. Gotten your du, should be 4x dx. Remember, we're solving for dx, so you get your du over 4x equals dx. Now I'm going to leave the bounds off my integral and just kind of rewrite this. I have x, I have the square root of u, and in place of dx, I'm putting what I solved for dx. Du over 4x. Alright, before I go any further, I'm going to change those bounds because remember, the 1 and 5 correspond to the letter x, and I'm using u in my problem now. So all I'm going to do is plug a 5 in to get my upper bound. So 2 times 5 squared minus 1, hopefully you got 49. Plug a 1 in to get my lower bound. 2 times 1 squared minus 1 should be 1. And then I'm going to clean up these x's, I can cancel those. And I'll rewrite it one more time. I'll pull out my 1/4 integral from 1 to 49. And I'm going to bring this radical u up to the top by making it u to the negative 1/2 du. So now I've got one function, one integral, in terms of one variable, u only. So hopefully a nice easy integral. I'm going to add my 1, which is 2 over 2, so I get u to the 1/2, divided by 1/2, or times 2. And don't forget you've got that 1/4. And there's no plus c, we'll stick our bounds on, 1 to 49. And again, it's personal preference at this point. I'm going to keep cleaning this up. I'm going to pull out this as a 1/2, u to the 1/2 from 1 to 49. So I've got my 1/2, square root of 49 is 7, minus the square root of 1 is 1. So I've got 1/2 by 6, which of course is 3. All right, so that's our u sub with our definite integrals, our integrals with bounds. All right, I think we've built up and we're ready for the ugly ones. Here we go. All right, tricky, tricky, tricky. This one's a little nasty. Now, it doesn't look any nastier than the other ones, but you'll shortly find out what I mean by that. So we've got the integral, no bounds here, x cubed root of x minus 4. So hopefully you're thinking right away that your u should be x minus 4. Now we'll take its derivative, that's just 1 dx, and I don't need to divide anything over. So I'm going to go ahead and replace my u and of course du here. Remember, we're substituting this into the dx. All right, now what's wrong with this? We can't integrate when we have an x and a u. So your first thought might be, well, holy cow, I did it wrong. I can't have the x and the u. I can't split them. I can't have two variables. What the heck? Maybe I need to pick a different u. Well, I don't think picking a different u is going to help us in this case, because the only other option I have is this x, and the derivative of x is 1, and that wouldn't cancel with this cubed root. So in fact, we did pick the correct u in our problem. Here's the tricky step. We got to get rid of this x somehow. So what we're going to do is we're going to go back and we're going to use your u equation. So let's go ahead and write down use the u equals x minus 4, and we're actually going to solve for x. So I'm going to add over the 4, I get u plus 4 equals x. And I've got to kind of do like a double substitution. I'm going to put this in place of x here. So I'm integrating u plus 4 cubed root of u du. So now it looks a little better. I at least have an integral in terms of only one variable. Now, still not perfect. I cannot split this integral up because we're not adding or subtracting. This is obviously u plus 4 times the cubed root of u. But all I can do is distribute this cubed root through my problem. So I'm going to rewrite this as u plus 4, and I'm going to call this u to the 1/3. And when I multiply, make sure we add exponents, so you can really think of this as 3/3, which is 1. So I've got u to the 4/3 plus 4u to the 1/3 du. And from this point forward, I don't think it's too bad. We'll just go ahead and integrate. We're going to add our 3/3, so hopefully you get u to the 7/3 times 3/7. Plus, I've got a 4. When I integrate this, I get u to, they add 3/3, 4/3 times 3/4 plus c. I'm just going to clean it up a little further. I've got my 3/7. My original u was x minus 4 to the 7/3. These 4's cancel. Plus 3, x minus 4 to the 4/3 plus c. And there you have it. That's kind of our tricky u substitution, where we do that double substitution. So if you didn't quite catch on, go ahead, pause it, replay it, and try it again. All right, I've got just one more for you, so it's not a super long video tonight. All right, let's go ahead and try one more tricky u substitution. This time we'll have a definite integral with bounds on it. So go ahead, pick out your u du, and solve for dx, and we'll see if we get the same thing. 2x minus 1. I get du over 2 equals dx. And again, that took care of my u. Now I'm going to do my substitution part. I'm going to put that in place of my dx. So again, I'm going to leave my bounds off for the time being. X over, this becomes the square root of u. Got my du over 2. All right, well, hopefully you're not thinking we did the wrong thing. We just have to do that tricky u sub where I need to go back and use my u to help me solve for x. So the other thing I'm going to pull out is this 1/2 real quickly. I'm going to pull out 1/2. I've got x over the square root of u du. And in place of x, so here I go, I'm going to rewrite my u and actually solve this for x. So I've got u plus 1 divided by 2 is equal to x. And I'm going to substitute that into my x. Okay, so I'm putting that in place of x. So I've got 1/2 u plus 1 over 2 divided by the square root of u du. So at this point I have a complex fraction. I'm going to again pull out a 1/2, and I'm going to have that as a 1/4 out front. U plus 1, and I'm just going to rewrite that as u to the 1/2 for now. Alright, so just to be clear, this is a fraction of 1/2, and I just pulled it out front, multiplied by that 1/2 to get my 1/4. So at this point, I would definitely say there's two different ways to go about it, and it depends what you're thinking. The first thing that came to my mind was make like a beaver and split. So I'll show you both ways, and again, whatever works for you, whatever came to your mind is probably the one I'd go with. I would rewrite it as 1/4, and again, I'm going to split. I'm going to divide each term by u to the 1/2, and I'll write it out in steps. U over u to the 1/2 plus 1 over u to the 1/2 du. And then I would go one step further. When I divide, I subtract exponents. So I would say this is really 2 over 2 minus 1/2 would be u to the 1/2, plus I would probably rewrite this as u to the negative 1/2 du. So that's definitely one option. My second option, and maybe this is what you were thinking of if you didn't think split, is I could certainly bring up the u to the 1/2. So I've got u plus 1, and that would be times u to the negative 1/2 when I bring it up. Now in this case, again, I can't integrate separately. I would have to take this u to the 1/2 and distribute it to both pieces. And when you distribute, don't forget to add the exponents. So I would think of this as 2 over 2. So I would get 1/4, 2 over 2 plus negative 1/2, so u to the 1/2, plus u to the negative 1/2. And you'll notice you'll get the same thing. Whatever you prefer is probably the method I would go with. I prefer to make like a beaver and split. That's what pops in my head usually, so I'm going to continue with this one over here. But again, you're going to get the same thing. So I've got my 1/4. I'm going to leave that out front. When I integrate, I'm going to get u to the 3/2 times 2/3, plus add my 2 over 2, u to the 1/2 times 2. And I'm changing my bounds, don't forget. Perhaps I should go back here and watch those bounds. My original u was 2x minus 1. So I'm going to rewrite that off to the side. My u was 2x minus 1. My upper bound was a 5, so when I plug that in, I should get a 9. My lower bound was a 1, and I think that'll end up giving me a 1 there. So remember, I've put my bounds in terms of u because I have the letter u in my problem. So always say to yourself, it's upper minus lower. So I'm going to leave my 1/4. I'm going to carefully plug in my upper. 2/3, 9 to the 3/2, plus 2 times 9 to the 1/2, minus the lower. 2/3 times 1 to the 3/2, plus 2, 1 to the 1/2. And then again, just carefully evaluate each function. So lots of mental math. It's 18 plus 6 minus 2/3 plus 2. And again, I'm just going to keep going here. That's my 1/4 is still out front of everything. 24 minus I'm going to call this 6/3, which is equivalent to 2, so minus 8/3. Again, I'm going to multiply this by 3 to get a denominator of 3. So that looks like 72/3 minus 8/3, 64/3 times 1/4, 64/12, which of course reduces to 16/3. So final answer of 16/3. Well, that's all I have for you tonight on our tricky U substitution. So hopefully we had a good review of just U substitution in general, and then 2 different ways it could sneak up on us having to do that double U substitution, so to speak. So have a great night, and we look forward to seeing you tomorrow in class.